Let's think about the light and its interaction with surfaces. This research, which studies the behavior of light, is optics. The study of optics contributes to the body of knowledge in visual cognition. However, that is not the whole story. Very briefly, the light is composed of photons. Photons exhibit both wave characteristics and particle characteristics. Color vision, I mean the perception of colors, is about wave characteristics of light. The photons that are reflected with different wavelengths lead to perception of different colors. In any case, photons are radiated by their major source, the sun, as well as man-made artifacts such as light bulbs, fluorescent lamps, and projection lamps. These photons illuminate surfaces. We perceive this illumination as brightness. Photons also follow a trajectory of straight lines after their emission by the radiation source. Then they hit to and reflected from many surfaces. This interaction between light and surfaces includes three basic types. One of them is transmission. By the term transmission, we mean that the light passes through the surface. The term transparent is used to describe surfaces as such. Another basic type of interaction is absorption. It means that the surface absorbs all the incoming light. This corresponds to full black surfaces in real life. This is because if a surface does not reflect any light, so if it absorbs all the photons that hit to its surface, we perceive that surface in black color. The third type of basic interactions between light photons and surfaces is reflection. So by the term reflection, we mean that the photons are sent back from the surfaces, mostly with some relative angle to the surface. The perfect reflective surface is a mirror. These are, of course, descriptions under ideal circumstances. In reality, it is impossible to isolate a single light photon that hits to a surface and to measure its direction in terms of the geometric descriptions such as angles relative to surfaces. That's because the interaction of photons with surfaces involve a mixture of all these basic types. For instance, they will play together to form complex types of interactions such as refraction. But these are appropriate working definitions that makes the science of optics possible. Having a closer look at optics also provides valuable information about how our visual system works. Eventually, we are interested in the information carried by reflected light, since that is the light that hits to surfaces before reaching to our eyes. However, the light and the knowledge of optics is not the whole story. There is an example that I want to show. This is called the inverse problem. The inverse problem describes an optical situation about how the external world is projected onto the retina. Suppose that we are looking at a tree and we perceive it as a single complete tree. This is because it is a complete tree. However, it is also possible to generate the same projected image on the retina, even if the tree is not a complete tree. So the importance of the inverse problem is that the retinal image in the two cases, assuming that we focus on a single eye, are exactly the same. How then we understand that the two corresponding objects in the external world are different than each other? I mean, one of them is a complete tree and the other is pieces of tree located in distance. This problem is solved by the brain. There are many visual cues that help us perceiving objects in depth. So depth perception is not only due to the presence of the two eyes, but it is also related to how textures are shaped, as well as our previous knowledge of the objects around us. So visual perception is not only a so-called bottom-up activity, but it is also top-down in that our knowledge of the visual world shapes our perception of it. All these observations suggest that to study visual cognition, we should go beyond the physics of light and optics. For this, we may start focusing on how we perceive objects by examining borderline cases. Visual illusions are good examples of those borderline cases, as you will see in the next lecture.